Welcome to Brain Vision.
This problem gives us the heat required to melt ice in kilojoules per gram, so 0.333 kilojoules per gram, and asks us to find the number of photons required for this process. So the first thing we want to do is calculate the total heat required for this process in joules, as that will allow us to compare it to the heat of a single photon, which we'll calculate later. So this, we just need to do some dimensional analysis. So 0.333 kilojoules per gram. We multiply that by the molecular weight of water, which is ice, 0.15 or 18.01528 grams per mole. So now our grams cancel. And we also want to get rid of this mole, and it tells us that we have 5.55 times 10 to the minus second moles of ice. So we can cancel these moles and find out that our total heat required is 0.333 kilojoules, or 333 joules, which is just multiplying that by 1,000. And this is what we'll want for later in the problem. So now that we have the total heat required, we can find the heat of a single photon, which is E equals hc over lambda, where h is Planck's constant, 6.626 times 10 to the minus 34th. Let's draw that a little cleaner, 34th, times the speed of light, which is 2.99 times 10 to the 8th. And we divide that by our wavelength, which is 6.42 times 10 to the minus 6th meters. And that gives us the energy of a single photon to be 3.086 times 10 to the minus 20th. And that's joules per photon. So now that we know the total amount of energy required, which is 333 joules, and the amount of energy per photon, 3.86 times 10 to the minus 20th joules per photon, we do this division to find that we need 1.079 times 10 to the 22nd photons. And that is our final answer.